Hello, can you hear me?
Good evening, sir.
Yeah, good evening. Uh, did you try the questions in the exercise?
Yes,
Or
sir. Yes, sir. Yes, sir. Yes.
tell me which ones are doubts?
Yes, sir. Yes, sir. Sir, question, yeah, exercise 11, question 24.
Mm,
Like construct the angle y if sine y equal to 2 sine x.
mm, Okay, struck the angle by sine x, 2 sine x. I think, see, sine y equals 2 sine x. In that case, uh, you have to find the angle y. So y will be what? Sine inverse of 2 sine x, right?
Yes, sir.
Basically, 2 sin x is some known value, and you have to say what is the y angle.
Okay. Miss, we have to write in that form only.
Yeah, and this is not just the only possibility. You can, this is one possible angle, but you can also say y can be n pi plus minus 1 power n into sine inverse 2 sin x, right?
Oh, okay, sir.
This will cover all possible y's, right?
Yes, sir.
This is according to the formula for sine theta, the general
Yes.
solution. Similarly, if they ask you, the next one is tan y is 3 tan x. So I'll say tan y is 3 tan x. I will say obviously the basic angle is y is tan inverse 3 tan x. But the general solution would be y is equal to n pi plus tan inverse 3 tan x.
Yes, sir.
Anytime you have y is equal to this, if you take tan of this, you will always get 3 tan x.
Yes, sir.
You understand what I'm saying?
Yes, sir. Understood.
Have you done questions in exercise 12?
Yes, sir. I have doubt in question. 1 second. Question 11. Secant theta minus 1 is equal to root 2 minus 1 tan theta.
Sec theta minus 1 is equal to 2 minus 1 into tan theta. So, okay. So sec theta minus 1 is here. If I square it, what will happen? It will become tan square theta and sec square theta and all, right?
Yes, sir.
Could squaring is one possible option. Is there any other option? I don't think so. So let's square it. Sec theta minus 1 whole square is equal to root 2 minus 1 whole square tan square theta. So you'll get sec square theta plus 1 minus 2 sec theta is equal to root 2 minus 1 whole square and tan square theta. Now, since there is a 2 sec theta term, it will be better if my quadratic is in the form of sec theta, right?
Yes, sir.
It cannot be converted to tan theta quadratic, right?
Yes, sir.
So I will convert this tan square theta. We know the identity, so we'll say root 2 minus 1 whole square. It is sec square theta minus 1.
Oh, yes, sir.
And here you have sec square theta plus 1 minus 2 sec theta. And now it's about simplifying this and solving the quadratic, right?
Oh, okay, sir.
So if you square this, what will come? 2 plus 1, 3 minus 2 root 2. We have 3 minus 2 root 2 sec square theta minus 3 minus 2 root 2, right? Hit this side. And on this
Yes.
side, we have sec square theta plus 1 minus 2 sec theta. So everything on this side, I'll bring on the other side. So you will get 1 sec square theta will get cancelled. You will get 2 minus 2 root 2 sec square theta, right?
Yes, sir.
Plus 2 sec theta. And the 1 will get removed. So you have a minus 3 plus 2 root 2 and minus 1, right?
Yes, sir. We have got it.
This is becoming minus 4 minus 2 root, right?
Yes.
Minus 2 root 2 sec square theta plus 2 sec theta and this equals 0. 2 can get cancelled. You have 1 minus root 2 sec square theta plus sec theta minus 2 minus root 2 equals 0, right?
Okay, sir.
So use the quadratic formula, you will get the values for sec theta from here, right?
Yes, sir.
And once you have sec theta values, you can convert it to cos theta values and solve that equation.
Yes, sir.
What is the next one?
Yes, yes. Sir, question 36 and 37. What is covered sign and word sign?
You have to ignore that. That is not in the syllabus.
Okay, so that was.
But before that, there are many questions. Have you done all of them?
Yes, sir. All of them.
How do you do 28?
Question 28.
Tan of pi cot theta, that one.
Yes, sir. So I done like 10 pi by 2 minus theta.
Which
Like
one
tan
have you
3
converted?
cot theta. Tan 3 theta is equal to tan pi minus 2, sorry, pi by 2 minus theta.
So cannot. How is it pi by 2 minus theta? It's pi by 2 minus pi tan theta, no?
Okay, that question 32. Yes, sir.
How have you done this 32 this question?
Yes, sir. 32, I like tan pi by 2 minus pi tan theta.
This side is this. Now what is the next step now?
Then I write pi cot theta is equal to n pi plus pi by 2 minus pi tan theta. Then I take pi tan theta there. And first, yes, I convert like cot is 1 by tan. Then make the quadratic and solve it.
How will you solve the quadratic? Tan square theta plus 1 is equal to n plus half tan theta will come. Now what? Tan square theta minus n plus half tan theta plus 1 equals 0. You have to realize that the equation will not have solutions all the time. Depends on the discriminant, right?
Yes, sir.
So here the discriminant n plus half whole square minus 4 must be greater than equal to 0, right?
Yes, sir.
So that
Then I
means n
solve.
plus half should be greater than equal to 2 or n plus half should be less than equal to minus 2. We
Yes,
have
sir.
n greater than equal to 3 by 2 or n is less than equal to minus 2 minus half. So minus 5 by 2, right?
Yes, sir.
n is supposed to be an integer. So basically the first integer on the positive side that you get is n is equal to 2, right?
Yes, sir.
N is equal to 2, 3, 4 you will get. And n is equal to, here the first integer that you get is -3, -4 and so on.
So, yes.
So there are no solutions if you have n between -2 to 1.
Yes, sir.
You understand what I'm saying?
Yes, sir.
So while solving it, you cannot blindly say tan theta is equal to something, and then I'll say the formula for theta is n pi plus something. But you
Yes.
have to also specify which n will be valid and which n will be not valid.
Oh, okay, sir.
Is there any other doubt in the chapter?
No, sir, not in.
Okay, then we'll move on to the next topic, which is chapter 7, which is basically sum and difference of angles.
Yes, sir.
And sum and difference of angles. And we have to learn about the trigonometric ratios of those sum and differences. So the idea is that I want to find out what is sine of a plus b, and I want to find it in terms of sine a cos b, sine b cos a, and things like that. And similarly, I want to find cos of a plus b, right?
Yes, sir.
So in the book, there is a geometrical proof, which is a little complicated. We will do a proof for this formula in a different way using complex numbers. But right now, you don't know complex numbers, so we'll do it later.
Okay,
So
sir.
when we learn complex numbers, the proof of this is super easy using complex numbers. So we will not be worrying about the geometrical proof of the formula here,
Yes,
which
sir.
is given. You can read it. If you understand it, great. It is a little complicated because you have to make many constructions and try to think of the geometry and which one is sine and what. But
Yes, sir.
we will see a much easier proof later. For now, we'll just remember the formula. Sine A plus B is sine A cos B plus cos A sine B. And cos A plus B is cos A cos B minus sine A sine B. Right?
Yes, sir.
Now, these two formulas, if you remember, everything else in the chapter is derived from here. So, you need to realize that we already had discussed that sine of minus theta is what?
Minus sine theta.
And cos of minus theta is what?
Cos theta.
Yeah. So these two things are there for us. So what we can do is use that to figure out the formula of sine of A minus B. So instead of B, I will put minus B here, right?
Yes, sir.
Instead of B, if you put minus B in the formula, you will get sine A. Cos minus B is same as cos B, right?
Yes, sir.
And this time sine minus B will be negative sine B.
Yes, sir.
So it will be minus cos A sine B, right?
Yes, sir.
So we get the formula for sine of A minus B is coming out to be sine A cos B minus cos A sine B, right?
Yes, sir.
How did this come? It came from here and using this facts, right?
Yes, sir.
And we replaced B with minus B, correct?
Yes, sir.
Similarly, cos of A minus B, what will that be? We replace B with minus B in this one, you will get cos A cos B plus sine A sine B, right?
Yes, sir.
Because again, this part the sign changes, this part the sign does not change,
Yes, sir.
correct? So now we have four formulas, one for sine A, two formulas which are the basic ones, and from there we got the A minus B formulas also, right?
Yes, sir.
Sine A cos B plus cos A sine B, cos A cos B minus sine A sine B, And from here we have gotten formulas for sine of A minus B and cos of A minus B, which became sine A cos B minus cos A sine B and cos A cos B plus sine A sine B, right?
Yes.
Now from here we can also derive the tan of A plus B formula, because tan of A plus B is sine of A plus B by cos of A plus B, right?
Yes. Yes.
So we'll write the ratio of these four terms. So we'll get sine A cos B plus cos A sine B divided by cos A cos B minus sine A sine B. And I don't want my tan formula to involve sine and cos. I want it to involve tan and tan, right?
Yes.
Because all the, for example, when I had a sine and cos formulas, they involved only sine and cos, right?
Yes.
When I have a tan formula, I wanted to have only tans. So what I will do is I will divide up and down by cos A cos B. Basically, the numerator also I will divide by cos A cos B, and the denominator also I will divide by cos A cos B, right?
Yes.
So what happens on the numerator? See, it becomes sin A cos B by cos A cos B plus cos A sin B by cos A cos B, right?
Yes.
And the denominator is becoming cos A cos B by cos A cos B minus sin A sin B by cos A cos B. And now you can clearly see that tan of A plus B is coming in terms of tans, because cos B gets cancelled, it is tan A. Cos A gets cancelled, it is tan B, right?
Yes.
This fully gets cancelled, it is 1, and this becomes tan A tan B. Right? You are getting basically this result, tan A plus tan B by 1 minus tan A tan B.
Yes.
Do you understand how this has come?
Yes.
Similarly, in this formula, now you can do tan A minus B. Put, instead of B, we are putting minus B. And we know tan of minus theta is minus tan theta, right?
Yes.
So this formula will now change and become tan A minus tan B by 1 plus tan A tan B, right?
Yes.
So basically we have found our sum and difference of all the three ratios, right?
Yes.
All of these formulas should be remembered, but ideally you don't have to remember it in one shot. You can remember the basic ones and see how to derive the rest.
Okay, sir.
You don't have to try to remember every formula at once,
Yes.
right? Now we'll go further. We will see many of the consequences of these formulas. So although already there's exercise 13 now that you can solve based on what we have done so far. Okay?
Okay, sir.
Exercise 13 stuff we have already done by now. Okay.
Yes.
The next thing that we will see is a situation that comes very often in trigonometry, where you have to do this. What is sine C plus sine D? We have to write this sum of two sines as a product of two sines or cosine. Okay. These are called sum to product formulas. Sum has to be converted to a product. Okay. We will
Yes.
also see the reverse, also we'll see product to sum. But the more important ones are sum to product. For example, I could ask you what is sin C minus sin D? What is cos C plus cos D? What is cos C minus cos D? Right?
Yes.
So sum and difference of two trigonometric ratios, I want to write in terms of product. Okay.
Okay, sir.
So how do we get those formulas? So what we will say is we have already derived sin A plus B and sin A minus B and all, right?
Yes.
We have already seen sin A plus B is sin A cos B plus cos A sin B.
Process. Yes.
And we have also seen sine of A minus B is sine A cos B minus cos A sin B, right?
Yes, sir.
So what happens if I just simply add? If I add, what will come? Sine of A plus B plus sine of A minus B should be equal to, you should see 2 sine A cos B, right?
Yes, sir.
Because this part gets cancelled.
Yes, sir.
So we are getting this result. Now think about it. If I call A plus B as C and A minus B as D, do you understand what I'm saying?
Yes, sir.
If A plus B is C and A minus B is D, you can see that 2A is C plus D. So A is basically C plus D by 2 and B is C minus D by 2, right?
Yes, sir.
But now putting this in this result, putting this stuff here, you will get sine C plus sine D is equal to 2 sine, what is A?
C plus D by 2.
Cos C minus B by 2, right?
Yes, sir.
So now we have derived our formula for how to convert a sum to a product, right?
Yes, sir.
We are getting 2 sine C plus D by 2 cos C minus D by 2. Are you understanding what is happening?
Yes, sir.
How did we do it? We did it in an indirect way. We first took the basic sine A plus B, sine A minus B, added it, we got this, right?
Yes, sir.
And now I know that I need sine something plus sine something. So let's call this as C and this as D, right?
Yes, sir.
As soon as you did that, you will get A is C plus D by 2 and B is C minus D by 2, and then we get our formula, right?
Yes, sir.
Exact same process we will follow, but this time we will not add, we will subtract.
Yes, sir. Then cos
If
A
you
sin B.
so if you subtract now, what will happen? You will get sine A plus B minus sine A minus B. Sine A plus B minus sine A minus B. This term will get cancelled now, right?
Yes, sir.
And you will end up with a 2 cos A sine B.
Yes, sir.
And we'll put the same substitutions. We will say again C is A plus B and D is A minus B. So then we are getting what? Sine C minus sine D is equal to 2 cos A was C plus D by 2, right?
Yes, sir.
And B was C minus D by 2.
Yes, sir.
So sine C minus sine D formula is coming as 2 sine C minus D by 2 cos C plus D by 2, right?
Yes, sir.
Are you understanding what is happening?
Yes, sir. Understood.
By the same process, you should be able to derive now cos C plus cos D and cos C minus cos D, right?
Yes, sir.
Again, what will we use there? We'll use cos of A plus B and cos of A minus B, right?
Yes, sir.
You should check the same process and see whether you are getting this or not. You should get this. 2 cos C plus D by 2 cos C minus D by 2. Okay.
Okay, sir.
And here you should get 2 sine C plus D by 2 sine. Notice here I am reversing the order. It is D minus C by 2. Why am I reversing the order? Because actually sine D minus C by 2 is the same as negative of sine C minus D by 2. Right?
Yes, sir.
The answer here is actually minus 2 sine C plus D by 2 into sine C minus D by 2. But I don't want to remember a formula with a negative sign here. So that's why I have written it like this.
Okay, sir.
This negative sine C minus D by 2 has been written as sine D minus C by 2. Right?
Yes, sir.
Do you understand the process by which you will derive these?
Yes.
You will say cos of A plus B is cos A cos B minus sin A sin B,
Yes.
and sine of A cos of A minus B will
Cos
be
A cos B.
plus sin A sin B.
Yes.
Now, once you have to do two things. You have to add, you have to subtract, right?
Yes.
When you add and put C is equal to A plus B and B is equal to A minus B, you should get this formula. When you subtract, you should get this formula, right?
Yes.
However, these four results are quite important, and it is good if you can remember them. Obviously, the memorization will not come immediately. You will be able to remember them only when you solve a lot of questions and exercises. When you
Okay.
do the questions by practice, you will remember it. Okay.
Okay.
But in case you forget, you need to know the derivations so that you can get it yourself. So that's why we are discussing the derivations of all of them, because it's important to know how it has come. Okay.
Okay, sir.
So that is your sum to product formulas. Again, there is an exercise based on that, which is exercise 14. So exercise 13, exercise 14, those you have to attempt. Obviously, the reverse of this is very easy, which doesn't need to be remembered actually. What I mean to say is product to sum.
Yes.
So if somebody says 2 sin A cos B, right, is equal to what? This is a product, I want to convert it to a sum. I will not try to remember this because this comes very directly. You just take sin A plus B and sin A minus B, right? Sin A plus B would give me a term sin A cos B, and sin A minus B is also giving me a term sin A cos B, right?
Yes, sir.
If you add them, the other term gets cancelled. So it is clearly sin A plus B plus sin A minus B.
Then C and D.
Huh?
Then we will write C and D here.
There is no need to write C and D because this is what the formula is asking us to do. The formula
Okay.
is asking us to convert product to sum. We have done that.
Okay.
You don't have to do C and D here. If it was, for example, 2 cos A sin B, right?
Yes.
Those terms also come from here only, no? Sin A cos B plus cos A sin B was here, right?
Yes.
And this was sin A cos B minus cos A sin B, right?
We will
So,
subtract now.
so obviously if I subtract these two, I should be able to get 2 cos A sin B, right?
Yes.
The thing is, you don't need to remember this, it is common sense, right?
Yes.
If I have to write this like this, I can just think about it and get what the formula should be, right?
Yes.
If it is a mixture of sine and cos, it is always going to be using a combination of two sine terms, right?
Yes.
But if it was something like this, 2 sin A sin B,
Then cos.
then it will come from the formula of cos, right?
Yes.
Cos A plus B was giving us a minus sin A sin B, and cos A minus B was giving us a plus sin A sin B, right?
Yes.
So obviously it should be cos A minus B minus cos A plus B, right?
Yes.
I hope you are understanding the logic what I'm saying.
Yes.
And if it was 2 cos A cos B, then it will be the plus of these two. Because the sine part will then cancel out, right?
Yes.
I hope you are understanding.
Yes.
Okay, so there is a small exercise 15 also, which is after this point. Exercise 15. Then the next section is about tan A plus B and tan A minus B. We have already done that. There is nothing
Yes.
much to discuss there. And now we can now derive all the formulas that we have not yet derived. Okay. So for example, now that we know how to do sine of C plus sine of D and sine of C minus sine of D and cos of C plus cos of D and cos of C minus cos of D. We know how to do these, right? This is 2 sine C plus D by 2 cos C
C.
minus D by 2. This is 2 sine C minus D by 2 cos C plus D by 2. This is, both will be cos here, cos. C plus D by 2 cos C minus D by 2. And this will be both signs, but one of them will be reversed. Right?
Yes.
You will not say C minus D by 2, you will say D minus C
D
by 2.
minus C.
Because we know these formulas, now we can derive the general equations that we had learned in the previous class. So for example, if you have sine x is equal to sine theta, right?
Yes.
Here theta is known, x is unknown. Okay.
Yes.
So basically we had learned in the previous class that x must be n pi plus minus 1 power n into theta, right?
Yes.
But we had not seen a derivation for that. Now we will see the derivation. Okay. So we will say sine x minus sine theta equals 0, right?
Yes.
And now I'll apply the second formula, sine c minus sine d, right?
Yes.
I'll get 2 sine x minus theta by 2 into cos x plus theta by 2 equals 0, right?
Yes.
Now you have to think of, okay, when is the product of two things going to be 0? You can have either sine of x minus theta by 2 is 0, or you can have cos of x plus theta by 2 is 0, right?
Yes.
Now you need to know that sine theta is always 0 for any value of pi, any integral value of pi, right?
Yes.
It is 0 for 0, it is 0 for pi, it is 0 for 2 pi, any n pi, right?
Yes.
So when will this term be equal to 0? When the angle here is any multiple of pi, right?
Yes. M pi.
So we should say that x should be 2n pi plus theta, no?
Yes.
This is a possible set of values for which this part becomes 0. Right?
Yes.
Now we'll say when is cos going to be 0? You have to realize that cos 90 is 0, so pi by 2 is 0. Again, 3 pi by 2 is 0. 5 pi by 2 is 0. You should check this on the unit circle.
Yes.
You will realize that 90 degree, 270 degree are all lying on the y-axis, right?
Yes.
Since they are on the y-axis, the x coordinate is 0, so cos is 0, right?
Yes.
So you can see that there is a clear pattern and it is odd multiples of pi by 2, right?
Yes. 2n plus 1 pi.
So it will be something like x plus theta by 2 should be, we will not use the same n, we can say 2m plus 1 into pi by 2, right?
Yes.
And 2 gets cancelled and you're getting x is equal to 2m plus 1 pi minus theta.
Yes.
So the two possible set of answers for us are even multiple of pi plus theta and odd multiple of pi minus theta, right?
Yes.
Do you understand what I'm saying?
Yes, sir. Understood.
Now notice that here, whenever n is even, it was even multiple of pi plus theta,
Yes, sir.
and when n is odd, it would become odd multiple of pi minus theta.
Yes, sir.
So technically, these two formulas have been combined into one formula by this.
Yes, sir.
Anytime you take any integer n, whenever n is even, it will be 2k pi plus theta. And whenever it is odd, it will be 2k plus 1 pi minus theta, right?
Yes, sir.
Which is what the answers came for us, no, here.
Yes, sir.
Do you understand what is happening?
Yes, sir.
This is how we got this formula. Earlier, we had not seen the derivation. Now we know how it has come. We have to use our sin C minus sin D stuff, right?
Yes, sir.
Similarly, if I want to get cos formula, cos x is equal to cos theta. So I'll say cos x minus cos theta is equal to 0. And cos c minus cos t formula is 2 sine x plus theta by 2 and sine theta minus x by 2 is 0, right?
Yes, sir.
So you get cases of sine x plus theta by 2 should be 0, which means x plus theta by 2 should be n pi, right?
Yes, sir.
X is equal to 2n pi minus theta, correct?
Yes, yes, sir.
Or you get sine of theta minus x by 2 is 0. So theta minus x by 2, this can be written as actually sine of x minus theta by 2 is 0 also. This is negative of sine of x minus theta by 2 is 0. Right?
Yes, sir. Minus will come. Yes.
So minus can be cancelled out and you can say x minus theta by 2 is equal to 2m pi, right?
Yes, sir.
No, not 2m pi, should be equal to m pi and then 2 goes on the other side.
Yes, sir.
Do you understand we are getting this now?
Yes.
So you are getting one set of solutions is even multiple of pi minus theta and one set of solutions is even multiple of pi plus theta, right?
Yes, sir.
So therefore the answer for this was written as x is equal to 2n pi plus minus theta.
Yes, sir. Understood.
Do you understand what is happening?
Yes, sir.
Okay. So basically this chapter 7 contains these things. There are 3-4 exercises. Okay. Many exercises are there. The only
Yes.
way to get very good in trigonometry is by solving these exercises. So I want you to try as many questions as possible, all 4 exercises as much as possible. Okay.
Okay, sir.
There will be questions that you will be stuck on. It's fine. First time when anybody does these exercises, you will get stuck. That is not a problem. But you need to try and practice as much as possible. The more you practice, the better it will be.
Yes, sir.
We will continue to the theory for chapter 8 because again, that also comes from the 2 formulas that we have started out with. So chapter 8 will talk about double angles or multiple and submultiple angles. Okay.
Okay, sir.
Multiple and submultiple angles. Again, we will start off from the same point, our basic formulas. Our basic formulas of sine, cos. Actually, we don't even need to use the other two, but these two will not be used so much. From our basic formulas of these, sine A cos B plus cos A sine B. And here you have cos A cos B minus sine A sine B. From these, now I can derive very easily new formulas for things like this. Sine of 2A, right?
Yes, sir.
Because I will
B
just
equal
put
to
B is equal to A, right?
yes, sir.
If I put B is equal to A, what will happen here? It will become 2 sine A cos A.
Yes, sir.
So that is the first formula. It's called double angle formula because you're taking sine of a double A, right?
Yes, sir.
Very important. These are super important, but you need to know how it is coming. It is very obvious also how it comes, right?
Yes, sir.
In this one, we will say cos of 2A, right?
Yes, sir.
We will
Cos
get
square.
cos square A minus sine square A, right?
Yes, sir.
And now there are 2-3 versions of this that you need to know because cos square A and sine square A, there is also a standard identity of cos square A plus sine square A is equal to 1, right?
Yes, sir.
So we can say cos square A is 1 minus sine square A, right?
Yes, sir.
And if you replace cos square A here with 1 minus sine square A, it will become 1 minus 2 sine square A, right?
Yes, sir.
Another version is if I replace sine square A with cos 1 minus cos square A, right?
Yes.
In that case, it will become 2 cos square A minus
Minus
1.
one.
So these are the three versions of the same formula, cos 2a, right?
Yes.
Now you also have a tan a plus b formula that we had seen earlier. It was tan a plus tan b by 1 minus tan a tan b, right?
Yes.
So again we will put a is equal to b in that, and we should get tan 2a also.
Yes. 2 tan A.
2 tan a by 1 minus tan square a.
Yes.
So everything is coming from old formulas. So you need to see the connections.
Yes.
Okay. Fine. So these are your double angle formulas. Now we can also see a triple angle formula. Suppose I wanted sine 3a, right? So that will come by doing what? Sine a plus 2a, right?
Yes.
Now using sine a plus b formula, I will have sine a cos 2a plus cos a sine 2a, right?
Yes.
You understand what I'm doing?
Yes.
Now
The
I will
cost to.
say cos 2a, I know the formula, right?
Yes.
I will say sine a, and I will use the sine version of it. Okay. So I'll say
Okay.
1 minus 2 sine square a. There are three versions of cos 2a, right?
Yes.
I'm using the sine version of it because I want the answer to come in terms of sine only, right?
Okay, sir.
Because it's a sine 3a formula.
Yes.
Plus cos a, and what is sine 2a? It is 2 sine a cos a, right?
Yes.
So you are getting sine a minus 2 sine cube a plus, this is becoming 2 sine a into cos square a, right?
Then we will put 1 minus sin square.
We'll put this here and we'll get sine a minus 2 sine cube a plus 2 sine a minus 2 sine cube a, right?
Yes.
Finally, we get 3 sine a minus 4 sine cube a. So we are getting the formula for sine 3a is equal to 3 sine a minus 4 sine cube a, right?
Yes.
Similarly, you can derive cos 3a also. Cos 3a will come out to be 4 cos cube a minus 3 cos a. You should check that derivation. You can do it
Okay.
yourself. It's the same process, right?
Yes. A plus 2.
And similarly, you can get tan 3a also. It will come as 3 tan a minus tan cube a by 1 minus 3 tan square a, if I am remembering correctly. So again, you should check the formulas are there in the book, and you should also try to derive it. Again, the same process. Okay.
Okay, sir.
So that is your double angles. Okay. Double angle, triple angle, and all. Right.
Yes.
3 tan a minus tan cube a by 1 minus 3 tan square. Yeah, that is correct. And that is your exercise 17. So far what we have seen is till exercise 17 theory. Okay.
Yes.
Exercise 17 is in the next chapter. Okay. So
Yes.
what you need to now do is work through like all of these exercises, see what the questions are you are getting, what doubts you are having. Basically, a lot of practice is required at this stage. Okay.
Yes.
The point is to remember the formulas by applying it many times.
Okay, sir.
So from the beginning of chapter 7 till chapter 8, exercise 17, that is the homework. Obviously, I don't expect you to do all the questions in the next class, but try as much as possible. The next class will not be new theory, it will be practice of questions.
Okay, sir.
Monday's class will be just practice problems. So we will discuss all the exercises and problems in that exercise.
Okay,
So
sir.
There is not much theory. Chapter 8, there is submultiple angles left. And after that, there are 2-3 chapters, and then we get to the main thing. The main thing in trigonometry is to learn about the properties of triangles, which will come in chapter 12 and chapter 15. So it is very easy to progress in trigonometry as long as you keep working on the things and learning the formulas. Okay.
Okay, sir.
So do this work, and we will continue on Monday with practice problems from or doubts from these exercises. Okay,
Okay, sir.
fine. That's all for now.
Thank you, sir.